the gradient is 0. Okay, let's just say where f prime of x is equal to 0. Okay, so stationary points is not only a single type. There are two types of stationary points. This is our number one, your turning points, and number two, inflection. Okay. Now, turning points. We discussed this one so this is not something new to you. Turning points is, as we know it, there are two types of turning points. We have here letter A, we have a maxima, and letter B, we also have a minima. Okay, maxima or minima. Since we already know, let's define maxima or minima, or let's give it a more in-depth definition, okay? Rather than we say that maxima is the highest value, minima is the lowest value. That was the definition I gave you several years ago. But now that we are in advanced mathematics, let's have a more in-depth or more deeper definition of these two. So what's a maxima and what is a minima? Okay, here. Okay, maxima point, correct? Yes?
Yeah.
Yes or no? Okay, so if we look at it closely, it is going to give us a zero gradient. Now, since it's giving us a zero gradient, we can actually define it using the point wherein or the range wherein we are going to have an increasing part or increasing function, and then its part which is now a decreasing function. So here at this part it goes up, so we can say that that is increasing, and then suddenly at the point or at this point it turns and changes or shifts to a decreasing function. Correct? So we can use that to define a maxima. A maxima is a point where the behavior of the graph changes. A maxima is a point where the behavior of the graph changes from what? From increasing to it changes or yeah, it changes from increasing to decreasing. There. Okay. That is now a good definition for a maxima. For a minima, it is now going to be the opposite of it. Okay. If you have this for a minima, the behavior is from higher value to lower value. So that means it is now decreasing. From here, on the other hand, after this point, there's a shift, goes up. Okay. So for a minima, we can now define this one as a point where the behavior of the graph changes. Okay, it is now a point where the behavior of the graph changes from going down first, original, it is now decreasing to going up. It's now going to be increasing. Okay, so which means we are still going to determine if it is a maxima or minima. We are still going to be using this one, your first derivative test. Okay, so we test the intervals from here to here. If it is increasing, then test it and compare it from the intervals from here to here. So if it decreases, then that means it is a maxima. If we test the interval here on this side of this one, of the first derivative, then it we got a negative value, so that's decreasing, and then suddenly become increasing value, then we know that this point is a maxima. Is this one clear?
Clear, teacher.
Yes, teacher.
Clear, teacher.
Okay, so I think now what is now the point of inflection? Okay, to understand what is the point of inflection, I need you to recall our exercises before with the containers. Okay, water containers. Okay. Where is that? Remember this container? And then we are going to fill it with water. So water
Yes,
is
teacher.
filling in. So what's the graph? What's the graph for this? Can someone recall what's the graph again? It will be from
uh, increasing
until this point.
works.
Until this point, how? It is going to be
In,
fast, fast to
Fast to
fast
slow.
to
It will
slow.
go.
fast to
Yeah.
slow. And then from here going there, it is now going to be slow to
Fast. Yeah.
fast. Okay.
And then
And then the next is going to give us like that. Okay. Yeah. But what my concern is here, this graph. So fast to slow, slow to fast. Okay. If I'm now going to analyze the tangent for this, the tangent here has a very, very steep gradient. Okay. And then suddenly as I go up, it's becoming lower gradient. Correct? Until such a
Yes.
time that it's going to flat out. It's going to flat out. Right? So if you analyze it, oh, it's going from high to low to low to low, low. So it's going down, right? So higher, lower value, lower value. But it reaches a certain value, what happens? Did it reach zero? It can reach zero, but once it reaches zero at that point, what happens?
It will start to increase again.
It starts to shift. There is now a shift, right? From here, it's going down. Okay, it's going down, but at this particular point, it shifts. It shifts and then becomes what? It becomes bigger, 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 right? There's a behavior, but it did not continue to decrease. It did not go to negative. It was going down, but then it suddenly survived and it went up. So there was a decrease, and then suddenly at that particular point, it went up. So there's a shift, but it did not again change direction. Okay, there's a shift, but no change, okay, in direction. It is still increasing. Okay, this is still increasing, increasing, but slow, right? From fast to slow, and then slow to fast. No change in direction. You understand what how I defined it?
I
This
don't
one,
understand no change in direction.
it is now increasing. Here it is increasing and increasing and increasing and increasing. At this point, it turns decrease, 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 decrease. Okay. Here it is now decreasing, 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 and then suddenly it increases. This one, there's no shift. There's a shift from increasing but going slow, from fast to slow, and then what? Did it change?
Yeah, too slow, too fast.
But then from slow to fast, but the behavior,
It's
no
still
change in
increasing.
direction. Here it
Oh,
is
okay.
now increasing, yeah, increasing at this point, but when it shifts, it only gets slow to fast, but it's still increasing. Okay, clear?
Okay, teacher.
So
Yeah,
this
clear.
is now called your inflection. Okay, that's your inflection. Um, I will